In this lesson, we're going to look at more problems using the ideal gas law or the combined gas law, but also see how we can distinguish which one we're going to use for a particular problem. A gas has a volume of 800 milliliters at minus 23 degrees Celsius and 300 torr. What would the volume of gas be at 227 degrees Celsius and 0.850 atmospheres of pressure? Our question is, do we use the ideal gas law or the combined gas law? As I look back through the problem, what I'm looking for is whether I have one set of conditions or two sets of conditions. And if I look at my volume, I see 800 milliliters and another mention of volume. I see two temperatures and I see two different pressures. Because I see two sets of conditions, this tells me I'm going to use the combined gas law. For condition set number 1, my volume is 800 milliliters, and I'm going to convert that to liters, remembering that the ideal gas constant has units of liters, so I'm going to keep all my units consistent. My temperature is minus 23 degrees Celsius, and I need to convert that to Kelvin, so I add 273 to get 250 Kelvin. My pressure is given as 300 torr, but I can't have pressures in two different units, so I need to convert torr to atmospheres. So I divide by 760 and get 0.395 atmospheres. I'm not giving anything about moles, so I don't need to worry about that for conditions 1. For conditions 2, I see my volume is my unknown. That's what I'm going to solve for. My temperature is 227 degrees Celsius, which I need to convert to Kelvin and get 500 Kelvin. And my pressure is equal to 0.850 atmospheres. Now I can write my combined gas law equation and begin plugging in my knowns and canceling out anything that's exactly the same on both sides. There's no mention of moles anywhere in the problem. There's no indication that we've added or removed any of our gas sample, so we know that N1 equals N2, therefore they can be canceled out. Now I can plug in my pressure and volume and temperature for my initial conditions, and then plug in the pressure as well as the temperature and the V2 for my unknown for the final conditions. Now I take 0.395 times 0.8 times 500 and get 158. I take 250 times 0.850 and get 212.5, which is equal to my unknown volume. I simplify that and find that my unknown volume is 0.744 liters. Because my original volume was given in milliliters, I can also write that as 744 milliliters. What is the pressure of a 2.5 mole sample of neon in a 0.75 liter container at 35 degrees Celsius? Again, the question is whether or not I use the ideal gas law or the combined gas law. When I look at the problem, I see one mention of pressure, one mention of moles, one mention of volume, and one temperature. Because I only have one of each variable, I know that I'm going to use the ideal gas law because I have one set of conditions. I know my pressure is my unknown because we're asked to solve for the pressure. Volume is 0.75 liters. Moles is equal to 2.5 moles. And the temperature is 35 degrees Celsius, which I must convert to Kelvin and get 308 Kelvin. Now I can plug in my values to the ideal gas equation. So I have my unknown pressure times the volume times moles times my ideal gas constant times the temperature. When I simplify this, I get 0.75 times pressure equals 63.19. I divide both sides by 0.75 to find my unknown pressure, and I get 84 atmospheres.